Clean, pure, fresh air and bright sunshine. It's great. We want it for ourselves and for our kids, but it takes more than just wishful thinking and a bunch of red balloons. We can't go back to the horse and buggy days. Bicycles certainly aren't the answer. And steam-powered vehicles haven't proven practical. Our best bet is the internal combustion engine. However, these vehicles must meet tough exhaust emission standards. Specifically, 1975 federal exhaust emission standards have cut 1974 hydrocarbon and carbon monoxide emissions to less than half. California emission standards have been tightened even more. Grams per mile for 1975 have been cut by about 3/4 from 1974 levels. But what's a gram? We all know what an ounce and a pound are. A gram is a lot less than an ounce. In fact, it takes just a little over 28 grams to equal only 1 ounce. One of the California emission standards for 1975 has been cut to even less than 1/28th of an ounce. That's only 9/10 of a gram, less than 1 gram per mile. Compared to the years before Chrysler introduced its clean air system, engines for 1975 have approximately a little over 85% of the hydrocarbon and monoxide emissions eliminated. But to reach that goal, engineers faced some serious problems. Briefly, lowering combustion chamber temperatures reduces the amount of oxides of nitrogen, commonly known as NOx. But hydrocarbon and monoxide levels generally increase. On the other hand, raising combustion chamber temperatures helps reduce hydrocarbon and monoxide. But NOx emissions increase. Therefore, in order to meet 1975 standards for NOx, hydrocarbons and monoxide, engineers had to use 2 different control methods. As in past models, the formation of NOx emissions is controlled inside the engine by the exhaust gas recirculation system. By diluting incoming air-fuel mixtures with inert exhaust gas, peak combustion chamber temperatures are lowered. That takes care of NOx. Hydrocarbon and carbon monoxide emissions are controlled externally by a catalytic converter, or an air pump, or using both. Now, the catalytic converter works on an unusual principle. Specifically, in the presence of oxygen, the catalyst causes the unburned hydrocarbons and carbon monoxide to be burned inside the converter after it leaves the engine. In Chrysler's new catalytic converter, carbon monoxide and unburned hydrocarbons are changed into harmless carbon dioxide and water. But exactly what's inside this new device? Let's see. Between the 2 stainless steel stampings that make up the shell are 2 oval-shaped ceramic cores. Each of the 2 oval cores have thousands of small triangular-shaped honeycomb passages. In fact, every square inch contains close to 240 of these passages. As a result of this unique construction, the actual inner surfaces equal the flight deck area of a large modern aircraft carrier. Roughly, that's about 195,000 square feet. Now, we need all this surface area because we want the unburned hydrocarbons and carbon monoxide to come in contact with a catalytic coating deposited on the honeycomb surfaces. It is this extremely thin film of 2 precious metals, platinum and palladium, that promotes the chemical reactions inside the ceramic cores and reduces unburned emissions. The ceramic cores are a special clay-like material baked much the same as chinaware. They are somewhat fragile and will break when subjected to shock. Protecting these expensive cores so they don't crack because of road shocks and jolts is the job of the stainless steel wire mesh. This mesh also protects the cores from shocks of extreme heat and cold and helps lock them in position when the 2 stamped sections are welded together. The shell and diffuser are stainless steel to withstand the higher operating temperature caused by the burning of hydrocarbons and carbon monoxide. The diffuser fans out the exhaust gases and prevents them from funneling into a small area of the cores. As the hot gases pass through the converter, the catalytic reaction takes place automatically, and normal internal temperatures rise to somewhere between 13 to 1600 degrees. Normal outer surface heat is about 1000 degrees. But even higher temperatures are reached if the engine is in poor operating condition or under a severe load. Converters are somewhat like a catalytic furnace. If they're fed too rich a fuel mixture, they easily hit temperatures exceeding 1600 degrees. For example, when spark plugs misfire, raw fuel is pumped into the converter. This sends internal temperatures soaring. More than 2 plugs not firing over a period of time can skyrocket internal heat to 2500 degrees or more and quickly destroy the converter. That's why pulling one spark plug wire or making a cylinder balance test in order to locate a weak cylinder must be done cautiously. For the same reason, cutting out one bank of cylinders when pressure testing the cooling system to track down a cylinder gasket leak can also damage the converter. Don't do it. Pouring combustion chamber liquids or carburetor cleaners into the engine sends extra combustible materials into the converter. That's taboo. Now here's something engineers had to consider. During a normal closed throttle deceleration from high road speeds, an excessive amount of unburned fuel also goes out with engine exhaust and enters the cores. Therefore, to prevent high converter temperatures from developing under this normal driving condition, all models with a converter are equipped with a new device called a catalyst protection system. This system includes an electronic speed switch and a throttle positioner solenoid. This is not the familiar curb idle solenoid used on some past models to prevent afterrunning when the ignition is turned off. This new throttle positioner solenoid keeps the throttle cracked open during normal decelerating from high road speeds. Here's how it works electrically. Pulses from the electronic ignition system are picked up at the ballast resistor terminal and then sent to the electronic speed switch. When engine speed exceeds 2000 RPM, the solenoid becomes energized by the signal it receives from the electronic speed switch. The extended plunger provides a new throttle stop position. If the driver releases the accelerator pedal when engine speed is above 2000 RPM, the solenoid plunger holds the throttle plates cracked open at the equivalent of a fast idle position. This slightly open throttle provides a sufficient flow of intake air to adequately dilute the rich fuel mixture entering the converter during normal deceleration. Thus, it is protected from overheating. When engine speed drops to about 2000 RPM, the solenoid is de-energized, permitting the throttle to return to normal idle stop position. Now for the gasoline. Engineers warn the motoring public to use only unleaded fuels. Converters can be damaged or poisoned by leaded fuels. Then catalytic action is destroyed and hydrocarbon and carbon monoxide levels jump upward drastically. To prevent service stations or motorists from using leaded fuels, there's a new fuel filler neck on the gas tank. A spring-loaded valve inside the filler neck can only be opened by the new, smaller, unleaded fuel nozzle. Only pumps dispensing unleaded fuel will be equipped with this nozzle. Warning decals provide another preventive measure against tanks being filled with the wrong type of fuel. Underbody protection against normal converter temperatures is accomplished by locating heat shields or barriers at strategic areas. Heat barriers found on many models also protect the automatic transmission, torsion bar, the rear shock absorber and luggage compartment. In addition, at the converter, the underbody floor pan is heavily shielded to protect floor mats from high heat levels. Inside the car, most models have additional heat insulation under the floor mats. This is especially important on cars equipped with a trailer towing package or vehicles with an air pump and catalytic converter. California models also have a guard below the catalytic converter. This is not a heat shield. Rather, it's a device to prevent objects from coming in contact with the hot converter shell. With all this shielding, You've got to be extra careful when using hoists or floor jacks. If heat shields, converters, or exhaust pipes are bent, crushed, or misaligned, reduced airspace restricts the free flow of cooling air. Heat buildup can become uncomfortable to passengers. Here's another precaution. Parts of the catalytic converter system and its shielding must be masked before spraying rust-proofing or sound-deadening materials. Failing to do so may cause more than an odor problem. Now, let's take a look up front. You're probably very familiar with air pumps. California pollution standards require added air injection so that engines can meet their more exacting emission levels. This extra supply of controlled air is piped into the exhaust manifolds on V8 engines or into the cylinder head on the 225/6. The extra air ensures more complete burning of hydrocarbons and carbon monoxide in the catalytic converter. This results in higher heat levels throughout the catalytic converter system. Now there's a new reminder light that signals the driver of the need for maintenance of his engine's exhaust gas recirculation system. The switch that controls this circuit is triggered by a counter mechanism connected in series with a speedometer cable. When the first 15,000 miles have gone by, internal electrical contacts snap together and complete the circuit. After required EGR maintenance is performed, turning the reminder light off is not difficult. Just a small twist of the reset screw zeroes the maintenance switch gears, the contacts open, and the system is ready to count the next 15,000-mile interval. In closing, remember this. Chrysler has done an excellent job of designing and building the new emission controls and systems so that our engines meet government emission standards while maintaining satisfactory drivability. But it is equally important for owners to have regular tune-ups and recommended maintenance of their anti-pollution systems. In a way, clean air is everybody's job.